Hey geometry students, today we are going to be dealing with precision and accuracy. So we're wrapping up chapter 1 of the geometry textbook this week, and then next week we're gonna assess the chapter. So we're gonna have our test next week. So precision and accuracy. Precision, right here, refers to the clustering of a group of measurements. It depends only on the smallest unit of measure available on a measuring tool. The absolute error of a measurement is equal to 1/2 the unit of measure. The smaller the unit of measure, the more precise the measurement will be. Precision in a measurement is usually expressed by a number of significant digits reported. So we're going to read this together, and then we're going to do the assignment together. I'm going to show you guys what we're doing. You'll see it a little bit more clear. To determine whether digits are considered significant digits, use the following rules. So these are the rules. Non-zero digits are always significant. In whole numbers, zeros are significant if they fall between non-zero digits. So that would be like 906. Then that zero would be considered a significant digit. In decimal numbers greater than or equal to 1, every digit is significant. In decimal numbers less than 1, the first non-zero digit and every digit to the right are significant. So let's do a couple of examples. Number 1, find the absolute error of 5.2 inches, then explain its meaning. I'm not really going to be too harsh on the explaining its meaning. I just want you to find what the absolute error would be. So if you notice, it says 0.2 inches. 5.2 inches. So that means that the given measure is to the nearest 0.1 inch. That's where we rounded it at. So if it's 0.1 inches, so the absolute error is we're going to multiply that by 1/2 or 0.5. And so 0.1 times 0.5 or 1/2 is 0.05 inches. That is our absolute error. That is our absolute error. If you can read that. Absolute error. I'm not worried about this part. It just means that you can be within plus or minus 0.05. If you notice, it would round up to 0.115, 0.2, round down to 0.5. So determine the number of significant digits in 60.07. This is a decimal greater than 1. So we're going to go over here. It's a decimal that is greater than 1. Every digit is significant. So we look at that. We go back. It's greater than 1. So since it's greater than 1, every digit is significant, so that means 1, 2, 3, 4. There are 4 significant digits. I'm going to do a couple problems with you. So 8 meters. Find the absolute error. So our unit is meters, right? And what our unit would be is 1 meter. So it would be rounded to so if we looked here, right, it was given to the nearest 0.1 inch. This means that our unit is given to the nearest meter. So we're going to start with 1 meter. I'm just going to put 1 meter, and we're going to multiply that by 1/2 or 0.5. So 0.5 of 1 meter is actually 0.5 meters. So that is our absolute error. It's just half of what we're rounding to the nearest. So this one here, 2.5 centimeters, it means that we're rounding to the nearest 0.1 centimeter. So we would start with 0.1 centimeters. and we're going to multiply by 1/2, which I can put as 0.5 if I want, or just 1/2. And 0.1 times 1/2 is 0.05. And our unit is centimeters. So that is our absolute error for that one. 3 1/2 feet. So what we're rounding to is the nearest half foot. So 1/2 foot times, again, I'm going to multiply by 0.5. But in this case, since it's a fraction, I'm going to multiply by 1/2. And so 1 times 1, top times top is 1. Bottom times bottom, 2 times 2 is 4. So our absolute error is 1/4 foot. So all we're doing is we're finding what we're rounding to the nearest unit, and we're dividing it by 2, or we're multiplying by 1/2. 6.25. So that means it's to the nearest 0.01 meter. So then you have to do 0.01, and I'm leaving this for you guys to do. But 0.01 times 0.5. 7 1/4 yards. So our unit that we're rounding to the nearest is 1/4 yards. So it'd be 1/4 times 1/2, which is actually 1/8 yards. 5 3/8. So this one's going to be a tiny bit tricky, because you might say, oh, we're rounding to the nearest 3/8, but that's not the case. We're actually rounding to the nearest 1/8 of an inch. So we're rounding to the nearest 1/8 of an inch. So if I did 1/8 of an inch times 1/2, I get 1/16 of an inch, because 8 times 2 on bottom is 16. So 1/16 of an inch. For these ones, determine the number of significant digits in each number. You're going to look at them, and you're going to go all the way back. And here's what I'm going to do. I'm going to actually copy this, and I'm going to put it there so that you can see the chart. So let's see. I wish I could crop this, but all right. So I'm just going to leave this chart right here for you guys. You guys can see it, and determine the number of significant digits. All you're doing is writing how many significant digits there are. This is 903.048, so it's a non-zero digits. In whole numbers, it's not a whole number. In decimal numbers greater than 1, that's the one that we're going to follow suit with. So number 7 goes to that rule. Number 8 and number 9 are both decimals less than 1, so they're going to follow this rule here. So I'll do number 8 with you. In decimal numbers less than 1, the first non-zero digit and every digit to the right are significant. So that means that this 5 for number 8, that's our first digit to non-zero digit, so that means that's our significant digit, but then every digit to the right of that is significant. So we have 503, so that means this is 3 significant digits. So that's all you're doing. And then you're going to have to do that for number 9 and number 7. So you have 2, 3, 4 questions to do today. If you have any questions, reach out. Thanks, guys.